Alright, so pull out yesterday's paper. We're going to start on question 6 here. We're going to go through these 3 problems. Make sure you are watching this through Delta Math so you get your points for it. Okay, so it says, given that A is the 0.17 and B is negative 3.2, find a formula that expresses the fact that an arbitrary point, meaning just some random point, P, X, Y, is going to be on the perpendicular bisector L of segment AB. So if we go back to our picture from yesterday, same points as A and B, we're just saying this is like our L, right? That is some arbitrary point on it. What would be a formula that would represent the scenario? Okay, so just like what we did yesterday, we know if some point is on the perpendicular bisector, remember we said it has to be equidistant from both A and B. Okay, why is that? Well, if we think about this, let me use green so it stands out. If some point is here on the bisector, that would form a right angle here. To figure out what this distance is, well, this is our A, this is our B. Over here we know that this would also be A and B. That C side would have to be the same to be that third side of our right triangle, because if two sides are the same and they're right triangles, by side angle side, you would know the third side was also the same. Okay, so let's think about what we said yesterday. We know it's equidistant from both A and B. So another way I could write that, the distance from A to P has to equal the distance from B to P. Okay, now how can we find our distance? Well, for A to P, let's set up the square root, and then it's x minus x, so 1 minus x squared. Or if you prefer, maybe I'm going to actually do this to make it a little easier on myself. I'm going to do x minus 1. It's still the same thing, but that way I'll have positive x squared. It doesn't really matter though. Plus then the change in y, so y minus 2, no, sorry, wrong one, y minus 7. Once again, how did I get that? Right here, these values. Okay, now all that will equal the distance of B to P, same thing, except now it's, once again, x minus negative 3 squared plus y minus 2 squared. Okay, now the good thing is, since there's just a square root on both sides, if I square both sides, those will disappear. Now I have x minus 1 squared and y minus 7 squared. That will be equal to x plus 3 squared and y minus 2 squared. Okay, now we're going to FOIL everything out. So x minus 1 squared, keep in mind, I'm not going to do this for each of them, but it's x minus 1 times x minus 1. So for that first one, it'll become x squared minus x, so minus 2x plus 1. And if you're not following, it's x squared minus x plus 1. Another shortcut, anytime you have something squared, a binomial squared, you can take the first part squared and the second part squared, and then in the middle you multiply them together and then times it by 2. That's how we get that negative 2x. So to follow that, this one will be y squared, then times it together, times by 2 would be minus 14y plus 49. Okay, that's on the left side, equals, same thing, x squared plus 6x plus 9. If you're not following that, you're going to have to write it out. X plus 3 times x plus 3 and then FOIL it. Okay, plus y squared minus 4y plus 4. Okay, at this point, we have an x squared on each side, cancel that out. A y squared on each side, cancel that out. Now let's combine like terms on the left. So we're going to have negative 2x minus 14y plus 50 will equal, and on the right side, combine like terms, 6x minus 4y plus 13. Okay, we're going to subtract the 13 over, add the 2x. We're trying to get a formula. Add the 14y. And on the left side, cancels, we're left with 37. equals, on the right side, 8x plus 10y. This cancels. So this right here is my formula. And if we want to double check it, I don't know if you guys remember in example 5, we had the point C from example 5, C was 4 1/2. We could plug that in here. Does 37 equal, so it was 4 1/2, that was point C. So 37 is equal to 8 times 4 plus 10 times 1/2. Well, that's going to be 37 is equal to 32 plus 5, so 37 is equal to 37. It did work out. All right, example 7 now. Example 7, here it says find the point with coordinates of the form negative 2a that is in the second quadrant and is a distance of 4 from the point P, which is negative 8, 2. Okay, distance formula again. One thing to remember, second quadrant. So that's somewhere up here, right? And so we take the square root, our distance formula, negative 2a minus, here I can do my minus 8. And then it's going to be a minus 2. That'll be squared, okay? And all of this we know should equal 4. Okay, so the first thing we're going to do is square both sides. I'll be left with this, negative 2a plus 8, all that squared, plus a minus 2 squared, all that equals 16. Okay, we square the left, each of those, that'll become 4a squared, let's see, minus 32a plus 64. Once again, write it down if you need to, plus a squared minus 4a plus 4. All this will equal 16. We're going to combine our like terms. So if we combine our like terms, let's see, we got 5a squared minus 36a plus, what does that become? 68, but then we'd subtract the 16. So 5a squared minus 36a plus 52, this equals 0. At this point, you can solve this many ways. I personally, when I see a problem this complicated, I'm just going to use quadratic formula because I know it's going to work. It's going to be a little tedious, but negative b, so that's 36, plus or minus the square root, b squared, so negative 36 squared, that comes out to 1296. Use a calculator. I don't have that memorized. I did it in a calculator. Then it's going to be 1296 minus 4ac. So 4 times 5 is 20. 20 times 52, that's 1040. It'll be minus that. All of this over 2a, 2 times 5, which is 10. Okay, what does that simplify to? It's going to be 36 plus or minus the square root of 256. All this over 10. And then from here, we get 36 plus or minus 16, all over 10. And that's going to split up to, what, 52 over 10, and then 20 over 10. Okay, at this point, we'll get both 2 and 5.2 as our two answers. Now, what are the points? It wants us to plug that in. Our original situation, negative 2a and a. We solve for the two values a could be. So negative 2 times 5.2. That point is going to come out to negative 10.4. 5.2. Is that in quadrant 2? Left and up, so yes. The second one, negative 2 times 2. That's going to come out to negative 4, 2. Once again, yes. And these are my two possible answers that both will have a distance from point negative 8, 2 of 4. All right. Next, on the back, we've got one more problem, okay? So, all right, this problem starts off the same. We want it to be greater than the square root of 5, okay? And there's one like this on your homework. So, we'll start it off, a minus 4, all this squared, plus, then it's 5 minus 3a, all that squared. This needs to be greater than 5. Okay, first thing we're going to do, oh, wait, sorry, greater than the square root of 5. Okay, first thing we're going to do is square both sides. I'm left with a minus 4, that quantity squared, plus then 5 minus 3a, that quantity squared. That has to be greater than just regular 5. Okay, now we're going to solve this. We're going to square everything. So that becomes a squared minus 8a plus 16. Once again, if you're not sure how I did that, it's a minus 4 times a minus 4. This next one plus 25 minus 30a plus 9a squared. Okay, all that has to be greater than 5. Combine like terms on the left, and we'll move that 5 over. So we're going to get 10a squared minus 38a. 16 and 25 gives us 41, but minus the 5 as we move it over. That's going to be greater than 0. We can divide everything by 2 here because they're all divisible by 2. If you divide by a positive, the sign does not change. So 5a squared minus 19a plus 18 is greater than 0. Okay, at this point we can use borrow payback. Some of you knew other methods, that's fine. Just we want to factor it. Now this is actually going to be a problem like what we did last chapter. So that comes out to plus 90. We can factor this. So a minus 10, a minus 9. We got to pay back the 5. So we see then that a minus 2 and 5a minus 9 has to be greater than 0. If it's greater, we know it's a positive. So if we think back to last chapter, my zeros, they're going to be, what, 9/5 and 2? So I need to set up my t-table, or not my t-table, my sine table. So negative infinity up to 9/5. If you want to change that to 1.8, you can. Then what, 9/5 to 2. This one then ends up being 2 to infinity. And what do I care about? Well, I need a minus 2, 5a minus 9. Ultimately, I need it to be positive. Okay, so plug in as 0. 0 minus 2 is negative. 0 times 5 is 0 minus 9 is negative. Negative times a negative, positive. It works for this. The next one, we'd plug in like 1.95. That's going to be negative. For the top one, it'll be positive. That means it's negative. Plug in a 3. That's going to be positive, positive, positive. It works for those two. There was no equal sign, so we cannot make a bracket. It's going to be negative infinity to 9/5 or 9/5, no, not 9/5, sorry, or 2 to infinity. Okay, now, this is great in interval notation. My answer, I need it in inequality form. So I could say a is less than 9/5, right? That's everything from negative infinity up to 9/5, or a is greater than 2. And this would be my answer, okay? On the delta, if you're doing a question like this, just create another answer by hitting the plus sign. You won't have the or. Just do a is less than 9/5, and then in the other one, you do a is greater than 2. So good luck. Get this done. If you need any help, please let me know, but try these problems, okay? Work together with your classmates. Get this done so that you are ready for Friday when I'm back. Have a great day. Bye.